Hi, welcome back for another 7 Caillou challenge. This one's called Number of People in the Bus. Basically, they give you a list of integer arrays. Notice it's an array and not just int. And the deal with those arrays is that it'll always have two values. The first value will say the number of people who are getting on the bus, and the second value will say how many people are getting off the bus. So you can kind of think of these pairs as like each bus stop, the sort of transaction that happens with people coming on and getting off. And so your job then, you notice it says to return an int, and this just represents the balance of people that remain on the bus after all of the stops have been made, if you will, or all these integer arrays have been processed. So I'm going to do my normal OCD stuff and format this a little more to my liking. You go ahead and pause. I think this one is easy for a 7 Caillou challenge, and you definitely got this. So go ahead and knock it out. Come on back. And I'll do my usual thing where I do a sort of basic building block solution, and then we'll do a one-liner using LINQ. So the way I went about this was I decided to create a local variable called balance. And this is the people balance. It's going to say our net amount of people, how many people we have on the bus at any given time. It's going to be the final result that I return here. And then the idea will be, of course, like I said, we'll return this, but we got to process. The idea is then that we go over the people list in out collection. We process each of these pairs, and each time we get a pair, we sort of update this balance. That's what my strategy is going to be. So I can do that. I'll use a for each loop because I don't care about the index value. If you need the index value at any given point, you can use a standard for loop, but for each, I don't need the index, so I like that one better. Each item in the list is an integer array. That's why I typed int array here with square brackets. You get to give it a name. I'll just call mine in out, and then the name of your collection. People list in out is what they called it. So that's the format of the for each loop. Your type, your variable name, then that keyword in, and then whatever your collection is. And you'll also notice people use var. Don't be intimidated by that. It's just that the compiler can figure out the type of in-out because it knows what people list in-out is. So it's just a shorthand. The nice thing about this is if you were to later refactor and change the collection type, maybe it wasn't a list anymore, it was an array of arrays, the var doesn't need to be updated. If you write out int array and then you change this to something else besides int array, you have to update that. Usually I write the type out unless, if it's really long, I like bar, but I find it to be more expressive just to write the type out, so I'll do that here. Either way is fine, whatever suits you. Okay, so let's grab each pair and update our balance each time. Remember, each time through this for each loop, we get to reference the in-out variable. That'll be updated every time through the loop with a new int array pair from people list in out. And what can we do? The instructions told us the first value is the people getting on. So I'm going to say we're going to add. I used the plus equals shorthand to add to balance. And then I want to subtract the number of people getting off, right? So the number of people getting on, number getting off. And this will keep looping through each time, updating in out with the next int array. So you can imagine by the time this for each loop completes, our balance is set. It's processed every one of those pairs. So you don't need the curly braces here, but let's go ahead and test this. Looks good. Green is golden. And there you go. Really not too bad at all, right? Hopefully you came up with this. Now we can go over the LINQ way if you want a one-liner. So let's do that. I'm just going to erase this because I'll submit mine. And the way I'm going to do this is an enumerable method that you should have seen if you've been with me for some time, but maybe not in the beginner series. Maybe. This enumerable aggregate. And so it does what it sounds like it does, but it's really general. It's not necessarily just adding. You could use this to do a bunch of multiplications or however you want to combine stuff. That's the beauty of this really general aggregate method. So go ahead and read this as much as you'd like to get a reference on that. You can check out the examples, but I'll show you one in our solution. Notice the returns is the final accumulator value. And so what we're going to do is we're going to use a seed value, they call it. Let me see. Source. I want the one specified seed value is used. Let's jump to this one. They should have a good example in here. So check this out. They make this array of integers and they call aggregate on it. And notice the 0 first. That means that's sort of your running total. Remember, it's going to keep adding to this seed value that you provide. So you give it the seed value with this overload, and then you give it your lambda, your anonymous function. You tell it how to process each integer element in the collection. In this case, they check if the integer is even. If it is, they add to it, so they must be counting even numbers, which the comment says right there. So we can use this format. And again, a lot of times we use lambdas with only one parameter, but notice how this one has two. It has total and it has next. So you do have to include parentheses around them and separate them by commas to get the syntax right. Note that total is going to start with your seed value there. And so your seed value it'll start at 0 and then it will increment by 1 each time your logic fires here. So we're going to do something like that. We can say return people list in out aggregate. And we want to return an integer, right? The number of people left on the bus, that total number, and I'm going to start it with 0, just like we did in the previous implementation. Remember, I had int balance equals 0. So now we get to make our lambda function. The first variable represents our balance, so I'll call it balance. You get to name these, just like when you make a method, you get to name the parameters. And then the second one represents each element in the list. In this case, well, it's a list. So I'll call mine in out. I think that's what I called it in the for each loop as well. So then we know we use the arrow syntax here to denote that we're now going to type the method body, the body of this anonymous method. And I shouldn't have even deleted the last one because we pretty much could have copy and pasted. We just want to do the same thing. We want to say balance. We want to update our balance every time and say in out 0, the number of people getting on, minus in out 1. And I could see I already made a typo there, the capitalization. I didn't camel case, that's what they call that, where you capitalize the first letter of each subsequent word in the variable name. And that's this. Remember, that was the same thing. You can even rewind the video and it should have been just like this. So remember, aggregate returns whatever this type is. I know a lot of the enumerable methods return another collection, an i.e. enumerable of whatever type you're working with, but this one will return an int. That's what we specified here. So this should work basically the same way. It's going through and getting each in out pair and it's adding to the balance appropriately. So let me test. Oh, I see one thing we did. Yep. Notice list int does not contain a definition for aggregate and no accessible extension method could be found. So what do? We go to aggregate. We didn't define it, right? We're counting on it being brought in. So when you want to bring code in and use it that somebody else made, you got to check the namespace. It's in system LINQ. So let's add that. Using system.link. And that error should go away. Looks good. Green is golden. Bam. So I'll stay with this nice short one-liner. People on the website seem to like that. Go ahead, submit. Again, probably not a lot of variation here. Okay, they summed them. Item 0. So that's cool. Yeah. Another enumerable That's kind of like what we did, right? They just broke it out into two separate statements. They added first and then subtracted. You could do it all at once. Yeah, a little variation there. But anyways, you know where to find me if you have questions, comments. Otherwise, I will see you in another video. As usual, thanks for watching.